Hey guys, I told you we could take a closer look at synthetic division with the idea that we did not get to dive into this as much as maybe we would have normally. And so wanted to give you a chance to review it a little bit before we get going too far into it. So synthetic division, remember, is just a tool in our math toolbox that helps us work with numbers and polynomials in kind of a stripped down kind of way. If you need to, if you don't like this review, you can always go to like YouTube and just type in synthetic division and have access to some resources in that respect. But for us today, I am going to just kind of walk you through one or two examples and talk about kind of where some things are coming from and how it all fits together. So here's what we're going to do. With everything we're doing, we're going to pull information from a graph. So I'm going to talk about this particular graph. X to the fourth minus 256. Lovely, lovely numbers. And this graph has kind of two key important places, and one of them does something like that. It does nothing like that. We'll go with it. We won't go with it. Basically, if you want to graph this on Desmos, great. Otherwise, it's important to know that there is a key point at 4 and a key point at -4. And for us right now, that feels pretty good. So that 4 and that -4 are going to be kind of tools in our synthetic division toolbox. And they are going to be the numbers that we divide with. Okay? So we're setting up the problem here a little bit. What we need to do is we need to set up synthetic division. So we have a box in the corner, and we have a line kind of dividing the problem from the answer. Okay? When I look at that problem, the number in the corner comes from the graph. So I'm going to put my -4 up here in the corner. Right? That's coming straight from the graph. And then I need kind of a home row of numbers. And I get my home row from right here. The only wrinkle is I have to count down and make sure I account for every part of it. So I've got a 1 from x to the fourth, or 1x to the fourth, and then a 0. There is no x to the third, so I put a 0 to hold that spot. There is no x to the second, so I put a 0 to hold that spot. There is no x to the first, so I put a 0, and then I finish with a -256. So 4, 3, 2, 1, blast off. 1 for x to the fourth, 0x to the third, 0x to the second, 0x to the first, and then -256. So we've assigned the numbers where they go. Okay, so if you remember, we did some stuff where we did all the setup, and then we did kind of the process. And the very first thing was we bring down that first number. And then we repeated over and over and over. Box times bottom. Bring it up. Box times bottom, bring it up. Box times bottom, bring it up. Box times bottom, bring it up. Anyway, I'm going to be a rapper. That's fine. Okay, so here's what I mean when I say all that. The first number, make it blue again. The first number drops straight down. It's a very complicated step, but you got to do it. Then the number in the box times the number in the bottom, -4 times 1, and then you bring it up. Then after that, we bring down. We bring down by adding. 0 plus -4. Then box times bottom, bring it up. Add going down, box times bottom, bring it up. Add going down, box times bottom, bring it up. Add going down. And we got a 0, and there's some key pieces that come with a 0, which is super cool. But that's kind of our result. For what we're doing, that's our result. If we wanted to, we could actually write this as x to the third minus 4x to the second plus 16x minus 64. And if you're wondering, the whole reason we do x to the third comes from the fact that when we kicked this off, this was x to the fourth, and after one round of synthetic division, now is x to the third, and then everything else just kind of follows after that. So that's where it's coming from. If you want to see a second example, let's see, what do we got here? Okay, x to the fourth minus 21x squared minus 100. When I graph this graph, right, I'm pulling numbers straight from the graph, which is super convenient. We get a point at 5 and a point at -5. Okay, so we could use 5. We could use -5. Whatever number we use exactly like it says on the graph. It doesn't change at all. So we did -4 last time. Let's do the +5. Positive numbers are good. So that +5 is my corner number. Right? It's my box number. My box times bottom, bring it up number. Give ourselves a little bit of room to do some math here. And then I need to set up across the top. Okay, so I got my green, and these numbers, 1x to the fourth, 0x to the third, -21x to the second, 0x minus 100 to seal the deal. And then we kick off our process. Bring down. Box times bottom, bring it up. Bring it down. Box times bottom, bring it up. Bring down. Box times bottom, bring it up. Bring down. Box times bottom, bring it up. Bring down. That's pretty sweet. So when we do synthetic division with 5, we get these numbers left. So we've done it with 5. I'm going to show you something really quickly. You can use these numbers again with -5. And why -5? Well, that's the other number I got from the graph. And so instead of redoing all the math, I'm just going to tuck it into a new box. And I'm going to repeat. Bring down. Box times bottom, bring it up. Bring down. Box times bottom, bring it up. Bring down. Okay, and so we've done that answer. So we can do synthetic division in rounds, so to speak, and that's totally fine. If we wanted to finish this particular round, we would say, okay, we started with x to the fourth, which is great. We now have x to the third, still great. Now we're down to x to the second, and that would be our final answer, x to the second plus 4. If you weren't quite, whoops, my bad. Oh, come on, there we go. If you weren't quite sure what was going on, you would have 0x here and a 4. I just didn't feel like writing the 0x, but that's technically what would fill that middle gap. So kind of a crash course review, synthetic division. Remember, you can always go to YouTube and get information that way. Otherwise, make sure you get in touch with me if there are still things that don't seem clear. Have a great day.